Okay, here we go. So, yes, we're finishing up this chapter. Great, that I made. So, as you can see by my labeling, I'm gonna change this. No, not this one. Where is this one? This one, right? To 1.1 because it's, yay, it's pretty much done. This is good enough for it to pass my test of it is wonderfully done. And well, so 1.1 is pretty much done, and then 1.2 is next. Well, yeah. Yay. But I'll explain why I think it's done by explaining GCD and LCM, greatest common divisor. Um, it's a common term if you look online. It's you can grab your phone and say GCM. To tell you the truth, I learned this with Gitan Swak, which is a Korean thing. Uh, and then I went to my school and learned it a completely different way too. So I actually um, took a while for me to get used to those two notations. So it might have code meshed to a weird combination of those two. Um, Either way, it's it's still a valid notation, and I think it's accurate enough that no one will get confused by it. Um, Let A and B be integers with a I would add both of and this was like elementary, so it's in my brain was trying to recall that and then yeah, it wouldn't come back to me, so luckily Chat GPT helped me a little bit to coax the formal definition out of my head. Um, Let A and B be integers with with my grammar is trash as usual. With both of them non-zero, we call an integer D a common divisor of A and B precisely when there's an existing M and N such that A equal dm and B equal dn. Um, I'll explain more. Honestly, the example makes it more clear than the freaking words. So yeah. Um, and the greatest common divisor, let A and B be integers with both of them non-zero. Common divisor of A and B is any integer such that you know this whole thing receives a whole number basically. The greatest common divisor denotes GCD, parentheses AB is the largest positive divisor. Yes, yes. So in school, let me see, let me explain how I learned the Gitan Swak and how I learned it in school. So this is Kitaswak, I remember. No, kind of. I code meshed it to make it translate to English, basically. Uh, but basically, it's the actually no. This is they both do it the same way. The least common multiple is where we differ. The way I learned it in school and learned it in other places. I'll explain. So, so we start with A equal 12 and B equal 18. And yeah, I'm trying to get all the I need to figure out who wrote this theorem over here because I'm trying to give credit to which where the real person that made it. Like Snell's law was made by Snell's law, and the Pythagorean theorem was not made by Pythagoras, made by some Egyptian guy, and Snell's law I think was Muslim. Um, Anyways, we have this, right? So we get D equals 6, D equal 3, D equal 1, and D equal 2. How did we get these magical numbers? No, we didn't get a magic. We just said, what can I divide 12 by? Well, 12 can be divided by 12. 12 can be divided by 8, 12. That is multiplied by 1. So, well, then. Basically, 12 can equal 12, 1. 12 can also equal 3, 4. Oh, that's how we got 3. But why not 4? 4 because it can be still divided into 2. So 12 divided by 2 makes sense with 6. Understood? So that's kind of what the logic was. And yeah, maybe I should make this diagram in here, but uh okay, maybe I should have see. Mm. Oh, maybe I should have. Oh, okay. Maybe I should have. Maybe I should have. Oh no. Oh, more work. Uh, by work I mean more graphing. Okay, maybe I should have done that. Um, the reason I'm realizing this is because as a kid you don't know. Maybe I could just explain it up over here instead. Somewhere over here. Eee. Because this graph, I absolutely detest this graph, honestly. Huh, 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 huh. Because I made this a long time ago, I don't like it anymore. Instead, I can give something like what a division, the fast way to do division or something, a little bit. Okay, yeah. Yes. Because this is still division. This is just division, and how I explained it over here. We can make a diagram over here, changing it, and I mean you can watch the process actually, because I'm not gonna turn off my computer. Instead, I'm just gonna do it. Understood? So let me change this. Delete. Um, let's do same thing, 12, right? Because I keep on using that number for no reason at all, honestly. Uh, okay. And I will use my mouse a little bit. Yeah, so we're just gonna say this and say 12, and then 1. 1 is all the thing you can do. Try it like this. Don't forget the circles, so I'm gonna really quickly do. Why is it not showing up? It usually does show up the traction, whatever, it doesn't matter. It's not like it's a life-threatening deal. Oh, we can just do 12 like this. I remember. 12 can be 2 and 1. Huh, doesn't do that with this one. Okay. Um, 3 and 4. We can just make lines like this. All lines. If you're asking, couldn't I just have used latex? Probably could have. Probably would have been faster than doing this. Yeah, I probably should have used latex for this later on. Um, yeah, honestly. Yeah, maybe I should just transition. But no, it looks fine. It looks awful. Okay, so what the fuck? Okay. Let me make this clean. Okay, there we go. Triangle detour. There you go. There we go. Better. Oh my God, took way too long. Okay. And I'm an aerospace person, so that means I'm gonna have to do CAD a lot, and it's a bunch of this stuff anyway. So just with CADing, and then let's make sure the uh 2.6, and we can explain how there could be a multiple version of it. And then here we go. Some reason that can show up. I think that is a much better diagram that could be used by someone. I don't know why. Mm, yeah, I mean, surely you'll find some use by someone. I'm starting to realize that the um you're definitely gonna need a talker to explain every step, definitely. But yeah, no matter what kind of textbook it is. So I'll just leave it be. I'm not gonna waste more time on that. It's not wrong. Okay, so well, at least that kind of adds up and makes sense a little bit. I never liked that diagram I made a long time ago, so I was trying to figure out something to change it with. Now I have one, so I'm just gonna stick with it. So what I'm gonna delete is this. So I have 6 and 3, right? 6 and 3. Um, D equal 2, D equal 12. Okay, so we have 6 and 3, 12. All right. Basically, what you find out is that there is in D equals 6, D equal 2, and D equal 1. That matches both of these cases. So if you look at 18 and 12, notice when I do 2, 9, 3, 3, obviously. I don't do it this way anymore. Um, it used to be a case. Used to do this. Um, well, that doesn't help that much, but we can realize that 2 and 6 equals 6 that way. Uh, so I purposely did it this way, but you could have done it faster by saying 3, 6 and 2, 3 by showing that there's a 6, 6. The reason I sh didn't do it was due to if you get a case and say 2, 9, because I don't know why. But 2, 9, and you think, oh, there's no common variable here. Well, if you multiply these two internally, that's 6, which gives you that. Um, and you can kind of see that fundamental over here, fundamentals over here. So these are prime numbers, basically, which we'll explain later. But basically, it's, I was writing and it didn't show up on the page. I never noticed. So sorry about that. Let me go back a few steps to explain to all of you what I meant. So let me erase this for a second so I can explain. So the first way I did it was 2, 9. And it takes a minute. 3, 3, how I got here. And if I grab these two, and you notice that this is a 6, and this is a 6 over here, you can get that. There's a faster way where I change this to 3, 6, and that would have gotten me the same thing, 6 over here, 6 over here. The reason I didn't do it is because you could have easily went, oh my God. You could have easily went with 2, 9, which I would have when I was doing this a long time ago when I was doing Gitan Swak. No idea what that is, huh? Or did I explain already? Probably didn't. I Yeah. Oof. Why did I have to say that? It's not like it matters. So yeah, I was I was thinking. Anyway, over here. Yeah. This reminds me how I didn't. I mean, this brings back memories of my elementary school because I didn't know where I was born when I was in elementary school. I was born in California, but I did not know that. So I had to ask my mom and dad in this because when I was doing this, I was asked a question somewhere, and I did not know it until I asked my mom and dad. It's weird. I was a dumb kid, I guess, elementary school. Um, Yeah, so yeah, anyways, the whole point is getting these fundamental numbers and matching them to the highest thing you can get. And here is six, and here is six, and you can match it. And the six is your GCD. That is the Kitaswakwe. The way I did it in here, the way I formalized it here was how I learned it in uh, American schools. That the public education system. Kind of. This I didn't learn. They just give you this. And by this, I don't mean this way. They give you a worser version of this, if I remember correctly, and they don't give you the negative versions at all. So yeah. I believe they don't do D equals 6. They just give you a bunch of multiplication, like 12 equals 6, 2, say 8, 3 or something. I don't remember. But they might have changed it. I don't remember. Anyway, yeah, that brings back memories. That was a weird thought I had. Anyways, yeah, USA, right? Worst education system. I can't say that really, but yeah, I mean, I can say that it's actually a factual fact in the age of 2025, because of the new math things, right? The core math stuff. That it's the same thing, honestly. It's the same thing. It's just what's the right word? I just feel like sometimes like. No, Madden's a language, so you can definitely explain it that way and still be fine. I don't really see a problem with it. Actually, why do I have a problem with Common Core? I don't. I don't. I generally don't. It's the lack of literacy rate or something that I'm more worried about, which I shouldn't care about because I don't even touch that stuff. I'm a student too in college, so well, why am I complaining about the American education system? Uh, yeah, because the test scores are failing, right? And then the math scores are failing, and everything's failing, right? No, 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 they're not, because I've seen the new age. And new age is not test orientated; it is recall orientated. So I'm babbling at this point. Maybe it's correct to not memorize anything. Maybe it's correct to mm, be that way. That's an interesting thought process. So what I'm saying is it's a good thing that they don't have. We should test them a different way because the way we're going to learn in the future is different. And I don't know what I'm saying. All right, see you later. No, no, I'm not done. So, don't go. I was just thinking my own rambling thoughts. I am not done with this explanation. Okay. Um, yeah, because yeah. I'm pretty sure if they ask you where's California, they would never know because they don't care because they search it on their phone. It's they probably don't even know that they probably do know that California and is a state, and then I don't know if they do actually know, but the U.S. I actually have no idea because I keep on seeing these videos on shorts that they don't know the geographic location of the United States. They show a picture of the United States. And you're better at drawing than me, and they don't even know where the what word that is. I remember that video and they're like, oh well, we're fucked. That's what I thought. But now thinking about it, maybe it's better that way because it's recall. I don't know. Maybe I'm just looking at a dumb making excuses for dumb ideas. Anyways, I'm babbling. I'm babbling. I'm so babbling. All right, least common uh multiple. And wait a second because it's going to take a while. Common multiple of a and b is any integer that m, I'm just going to say integer, this is an integer, such that a divided by m and b divided by m, the least of those is the smallest common multiple. What does that even mean? So what you do is say for a equal 4, b equals 6, find the you just say n equal 1 comma 3 comma 4 comma 5 comma 6, um and then um well, you just find a multiple of 4 and 6. And what you basically say is 4 multiplied by 1, that's 4. 4 multiplied by 8 is 4 multiplied by 2 is 8. For 12, 16, 20, 24, and you can keep on going. 28, 32. 36, and so on and so on. You probably find a lot more. And then you go with the multiple of 6, to say 6, 12, 18, 24, 30, 36, and so on and so forth to 42. You get the point. And then you match them. You say, oh, this one, okay, this one, this one. And you see the commonalities. In the over here, I stick to it only two of them because I knew LCM means the least, so it's 12, but you could have perceivably gone further, finding the common multiples. Now we're going to prove this fact here, which is a fun fact. Okay. And sounds intimidating. It's not. Let's be clear. It's not intimidating at all if you know what you're looking for. So, first thing I have to say is that we're going to go for composite first. What does that even fucking mean? Anyways, I just realized, luckily not a lot of people watching my videos, which is a good thing because I say some off-brand stuff in my video because of my yapping system. I yap a lot, so it keeps on going. Anyway, A equal dA pri and B equal dB pri, right over here. Now these over here, you're gonna have to note this down. Note this down a little bit. So I call it composite, but they're not really composite numbers as you would find out. So let's see, for A equal 12 and B equal 18, you find that 12 can get 6 and 2, and 18 equals 6 and 3. Where I got this number is finding from the GCD, where D equals 6, and then A comma equal 2, and B comma equal 3. These are composite because they form the the final. They form, what am I saying? Something is wrong. Something is clearly wrong. No, everything's right. Yeah. I for a second thought it was wrong. Um, yeah. So the composites form the numbers at large, and you see the D is what you know is the greatest common So you get that. But these are I made another example because this example I realized can be mistaken for prime, which is not prime. Um, prime numbers. When I say prime, I don't mean the prime drink. I mean prime numbers. A equal 36 and B equal 14. I gave another example because I realized that yeah, you can mistake that for maybe there's a relationship there or something like that. No, there isn't. There clearly isn't because if this goes over here, which is 18 multiplied by 2 and 14 multiplied equal 7 multiplied by 2, this goes to 2 and 9, and this is just there's 2 is a GCD, which means this equals 6. Um what, not 6, the D equals 2, sorry. And then you get to A comma 18 and B comma uh what was the last one? Oh, you can't see it. Okay. B comma fuck. 7, right? 7, yeah. Anyways, I'm just gonna keep on going like this because it's so much easier than I'm gonna keep on swiping because it's easier to deal with. Anyways, next we will go with what am I doing next? We're gonna just show something off. And that phi. Um, this is I know in the proof we're not supposed to, but it gives you a general idea of there's certain relationships that you get form with this. Um, Now the first relationship is AB equals this. Now, what does that tell me? Nothing much, but AB equal how do I figure that out? It's just we define A equal to A prime and B, so we just substitute. And this I found out equal GCD A comma B parentheses A comma DB. Why the hell did I do that? Well, I just want to show you where one of the D goes off because in here there's two D's and we know one of the D's we could just bring it back to GCD, right? No foul play. We already have one of them. Now, I'm going to assume A and B is positive due to GCD parentheses A prime, comma, B prime equal 1. Okay? Capiche? Capiche? Okay. I think we're capiche. Uh, yeah. So, we know that's true. We know that's true. Oh, um, but now we have a problem with A prime and DB prime. This, for that inequality proof to be true, must equal ICM. Now, the first thing I want to show is certain properties of it, which A prime dB prime divided by A, which equals B prime. Now, this gives you uh, a memorable idea why it, it because this is equal to because I divide everything by A, you're left with B over here, and you're given B prime in the end over here, right? No, not sorry. Multiply by G C D. If I was to give you this, right? Do you get what I'm trying to say? Okay, maybe not. This is this is saying I get let me give you AB equal GCD and then parentheses A comma B parentheses and then we're given A prime B prime and let's divide that by A. That will give me B equal GCD parentheses A comma B and then this will cancel out leaving us with this because I showed you earlier that A is BA prime and this is B prime like this. Now uh, this over here is what changes everything from this to this. We got the original equation basically. That's what I'm trying to say, right? It's a sanity check kind of because we said A equal D A prime B equal D B prime, and that's what basically is happening over here. And remember definition of A dot A divided by M and B divided by M. So in the end of the day, we get this format. Why do we need that? Like we need that.